Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva sir from Student the Brand. So now we'll discuss. Today topic is human eye in colorful world. Human eye in colorful world. Most sensitive and sensible topic. So human eye and colorful world. Myopia, 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 myopia. Near distance we can see far distance. Near distance we can see far distance we can see. Myopia, 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 myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, hypermetropia. Convex lens, convex lens, hypermetropia, hypermetropia, convex lens, convex lens. So that is about myopia and hypermetropia. Myopia and hypermetropia. So myopia we can see near distance, we can't see the far distance. For correction we are using concave lens. For hypermetropia we can see far distance, we can't see the near distance. For the correction of hypermetropia we are using convex lens. Now we will discuss about eye parts and function. So today completely we'll discuss about eye parts and function. So first we'll go to the eye parts and function, then we'll go to the myopia, hypermetropia, hypermetropia, presbyopia, cataract, astigmatism, and so we can go through the refraction through the prism, refraction through prism, and one more point is through water droplet. So rainbow formation by prism, rainbow formation by water droplet, and atmospheric refraction, scattering of light. So this all we will discuss. Okay, so we will discuss about We will discuss about eye parts and function. Now we'll see eye parts and function. So I'm considering here. So I'm taking. So while drawing the eye diagram, so I'll give how to draw the diagram. Okay, I'll show you how to draw the diagram. Just check it once. How to draw the diagram. I'll check. So check once here. Okay. So like this you have to draw the eye diagram. Like this you have to draw eye diagram. Okay. Eye lens you have to place. So what is the lens is there inside of the eye? That is convex lens. This is a convex lens. So these are the ciliary muscles. So this is about human eye. Human eye. Okay, right. So this is about eye. This is about human eye. Human I am considering. Human I am considering. Yes or no? Now the parts and function. So we'll discuss about parts and function. We'll discuss about parts and function. So now you can look at the board. So I'm considering here this is a cornea, the front layer, protective layer of the eye, cornea, ciliary muscles, ciliary muscles, and these are also ciliary muscles, ciliary muscles. Okay, so this is the iris. This also iris, and people, aqueous humor, aqueous humor. So this thing, vitreous humor, This portion is called vitreous humor. Vitreous humor. And retina. Retina. Optic nerve. Optic nerve. So this is about human eye parts and function. This is about human eye. Human eye. So we'll discuss human eye parts and function. Human eye. Human eye. And islands. Islands also there. Islands. 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 This is about this is islands. Islands. Okay, these are the parts. These are the parts. Now you can see. Now you can see. Okay. So the cornea is the frontal layer, protector layer of the eye. Cornea is the frontal layer, protector layer of the eye. Most of the refraction takes place at the cornea. So here at cornea, most of the refraction takes place. It is a frontal layer, protector layer. Most of the refraction takes place at cornea. Takes place at cornea. And here you can see ciliary muscles. Ciliary muscles. When you are seeing the nearby object as well as far by object, when you are seeing the nearby object as well as far by object, so here in human eye, so we have convex lens. This is a convex lens. Ciliary muscle adjusts the curvature of the eye lens to see the nearby object as well as far by object. So to see the near distance object as well as far distance object. Okay. So ciliary muscles will adjust the curvature of eye lens. If you are seeing the nearby object, the thickness of the eye lens will be more. Thickness of the eye lens will be more. Then focal length will be decreases. We can able to see the nearby object. When you are seeing the far distance object, so thickness of the eye lens will be less. So the eye lens will be thin. Focal length will be increases. By that we can able to see far distance object. So near distance object means eye lens thickness will be more, focal length will be less. We can able to see nearby object. So if you are seeing the far distance object, eye lens become thin. Focal length increases. Then we can able to see the far distance object. So that is the use of ciliary muscles. Ciliary muscles will adjust the curvature of the eye lens. Ciliary muscles will adjust the curvature of the eye lens so that we can able to see the nearby object as well as far distance object. Nearby object as well as far distance object. So this is about ciliary muscles. And next one, iris. Iris is a dark muscular diaphragm. Iris is so this is the iris. This portion is the iris. This two portion is the iris. This one and this one. Iris is a dark muscular diaphragm. Which controls the size of the pupil. Iris is a dark muscular diaphragm which controls the size of the pupil. Pupil will control the ear. So this is the pupil. This gap is called pupil. This gap is called pupil. Pupil will control the amount of light entering into the eye. Pupil will control the amount of light entering into the eye. Pupil will control the amount of light entering into the eye. So this is the pupil will control the amount of light entering into the eye. So this is the eye lens. Whenever the light ray falls on it, it will converge the light rays and make it falls at retina. Eye lens is a convex lens. Whenever light ray falls on it, it converts the light rays and make it falls at retina. So here one more part is there, that is the aqueous humor. Aqueous humor is a jelly type liquid present between eye lens and cornea. Aqueous humor is a jelly type liquid present between cornea and eye lens. So it gives the so cornea is the So aqueous humor is a jelly type liquid material. Aqueous humor is a jelly type liquid material present between aqueous humor is a jelly type liquid present between cornea and islands. Cornea and islands. Okay. So it is a jelly type liquid present between cornea and islands. It gives the sufficient blood and nutrition to the central cornea. And coming to the vitreous humor. Vitreous humor is a jelly type liquid present between eyelids and retina. Vitreous humor is a jelly type liquid present between eyelids and retina. Vitreous humor is a jelly type liquid present between eyelids and retina. Eyelids and retina. It provides the sufficient force and pressure. It provides the sufficient force and pressure to maintain that shape. And the retina is a light sensitive screen. Retina is a light sensitive screen where most of the where light rays will meet. Retina is a light sensitive screen where retina is a light sensitive screen. There light rays will meet. Image will form. What type of image will form? Real and inverted. What type of image will form at retina? Real and inverted. Retina, real and inverted image will form. Real and inverted image will form. Real and inverted image will form at retina. So there are two light sensitive cells are there, rods and cones. Rod sense the intensity of the light. So there are two light sensitive cells. One is rods, and the second one is cones. So first one is so here retina, rods and cones. Rod sense the intensity of the light. Cone says the color of the light. Rod sense the intensity of the light. Cone says the color of the light. Okay, that is about retina. So here, what are the images forming at retina? That is real and inverted. That will convert into electrical signal that will pass to the brain through optic nerve. Optic nerve is a nervous, so it will carry the signals to the brain. Okay. Here, and one more. Whatever image is forming at retina, that is real and inverted. We are seeing only 2D image. So if the signal is reaching to the brain will add the additional information. To see the 3D object. Yes or no? To see the 3D object. So that is about the eye parts and function. Okay. So we discussed about once again. So we will discuss all about cornea and ciliary muscles. Islands is a convex lens where whatever the light rays falls on it, converge the light rays and make it falls at retina. So that is islands. And the next one, people, iris, aqueous humor, ciliary muscles, vitreous humor, retina, rods and cones, optic nerve, and so this is about eye parts and function. Now near point is nothing but the person can able to see clearly without any strain. The minimum distance up to which a person can able to see clearly without any strain or pain, that is called near point. Near point is 25 centimeter for normal healthy person. Far point, the maximum distance up to which a person can able to see clearly without any strain or pain, so distinctively, so without any concern, then that is called maximum point. Maximum point is infinity for normal healthy person. So near point is 25 centimeter for normal healthy person. So the range of vision is 25 centimeter to infinity. The range of vision is 25 centimeter to infinity. I hope it is very clear. So the near point is the minimum distance up to which a person can able to see clearly without any strain, so we can able to see the object distinctively. Okay, so distinctively without any strain, that is called least distance of distance vision also. So the minimum distance up to which a person can able to see clearly without any strain or pain, that is called least distance of distance vision. Okay, so that is a 25 centimeter. 25 centimeter. 25 centimeter is a near point. Far point is infinity. The range of vision is 25 centimeter to up to infinity. 25 centimeter to up to infinity. So this is about near point and far point and the range of vision. Range of vision, right? Yes. Now, power of accommodation, ability of the islands to adjust its focal length, ability of the islands to adjust its focal length to allow the light inside of it. Ability of the islands to adjust its focal length to allow the light to pass inside of it is called power of accommodation. Power of accommodation is nothing but ability of the islands to adjust its focal length. Ability of the islands to adjust its focal length is called power of accommodation. Power of accommodation. Power of accommodation. So ciliary muscles are responsible for the power of accommodation because ciliary muscles will adjust the curvature of the islands. Ciliary muscles will adjust the curvature of the islands to see the nearby object as well as far object. Far object. Yes or no? So that is about ciliary muscles. Next one, ciliary muscles use, and that is also called a power of accommodation. Next one, we are going to the myopia. Myopia is nothing but, as I said, near point we can see, far point we can't able to see. So myopia, 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 myopia. Near distance we can see a far distance we can't see a myopia, 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 myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Okay, so that's enough. That's enough. So you are seeing here, we can see near distance, we can see near distance, we can't see the far distance object. We can see near distance, we can't see the far distance object. For the correction of myopia, we are using concave lens. Concave lens. Concave lens. Concave lens. For correction of myopia, we are using concave lens. Concave lens. Yes or no? Concave lens. Right. So we'll draw the diagram. We'll draw the diagram. How to correct the myopia effect. So we'll draw the diagram. Yes. Are you ready? So I'll tell the small concept. So very important logic. Very important logic. Very important logic. That is very important logic. So as I said, we can see near distance, we can't see the far distance object. Yes or no? Yes or no? We can see near distance, we can't able to see the far distance object. For the correction of myopia, we are using concave lens. For the correction of myopia, we are using concave lens. So now you can see here. So this is a 25 centimeter. and this is infinity. Okay, as I said, the person can able to see clearly. The person can able to see clearly near point, but he can't able to see the far distance object. Yes or no? Yes or no? The person can able to see clearly near point. He can't able to see the far distance object. Far distance object. Far distance object. But between 25 to infinity he can see. Between 25 to infinity. Between 25 to infinity. In between that he can see. That is 4 point of myopic eye. 4 point of myopic eye. The person cannot able to see the far distance object, but he can see between. He can see between 25 to infinity. 25 to infinity. 25 to infinity. In between that he can see. That point is called. That point is called. That point is called 4 point of myopic eye. 4 point of myopic eye. Yes. Now I'll draw the diagram. How it will be. How the diagram. So how you are considering. We will see now. So if the light rays are coming from this point, if the light rays are coming this point, from this point he can able to see. From this one, if the light rays are coming from far point, he can able to see. So those light rays will meet at retina. Those light rays will meet at retina. So now we can observe. So now we can observe. This is about. Now we can observe here. You can see this is about a far point of myopic eye. The first diagram is far point of myopic eye. First diagram is far point of myopic eye. Second diagram is light rays are coming from infinity. Second diagram, light rays. The dotted lines represent light rays are coming from infinity. If the light rays are coming from infinity, where image will form? Where image will form? Image will form in front of the retina. Image will form in front of the retina. Yes or no? Image will form in front of the retina. So here, so that's the reason we can't able to see the object. That's why we can't able to see the object. If the light rays are coming from infinity, if the light rays are coming from infinity, we can't able to see because light rays are meeting in front of the retina. Third diagram. Third diagram is correction of myopia. Correction of myopia. Far point of myopic eye. So now we can observe here. Now we can observe what are we are considering. So this is the concave lens. For correction of myopia, we are using concave lens. Concave lens. This is a concave lens. Yes or no? Concave lens. Concave lens. We are using concave lens to correct the defect of myopia. 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 So you can observe here from this. You can see this diagram. You can see this diagram. So first diagram, light rays are coming from this point. Light rays are coming from far point. So the person can able to see. If the light rays are coming from far point, he can able to see. So that's why that is the first diagram. Coming to the second diagram. Second diagram, light rays are coming from infinity. Infinity point, he can able to see. That's why light rays are meeting. Light rays are meeting in front of the retina. In front of the retina. Light rays are meeting in front of the retina. Yes or no? Yes. So the light rays, so we are using concave lens. Concave lens to correct the defect of. To correct the defect of myopia. To correct the defect of myopia, we are using concave lens. Yes or no? So this is a PowerPoint. Generally we can mention just F. No need to write FM. So just you can mention F. Right? Yes or no? So this is about cornea. So this is the far point of myopic eye, far point of myopic eye. And here this point we can say correction of myopia. Correction of myopia. Is it clear? So I'm going to the hypermetropia. 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 So hypermetropia is nothing but hypermetropia. The person can able to see yes or no. So we'll see if the light rays are coming from infinity. Light rays are coming from infinity. He can see, but light rays are coming from near point. He can't able to see. Hypermetropia. 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 Far distance. Far distance. We can see. Far distance we can see, near distance we can see. Far distance we can see, near distance we can see. For that correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, convex lens, hypermetropia, convex lens. Now, so we are going to discuss about hypermetropia. Hypermetropia. Check once. So, hypermetropic eye, the person can able to see far distance object. Hypermetropic eye, the person can able to see far distance object. He can't able to see near distance. Person can able to see far distance object, but he can't able to see near distance object. Person can able to see far distance object. He can't able to see near distance object. So, but between 25 to infinity, somewhere he can see. Between 25 to infinity, somewhere you can see. So in between 25 to infinity, he can see. That is a near point of hypermetropic eye. Near point of hypermetropic eye. So the person can able to see far distance, he can't able to see near distance, but between 25 to infinity can see somewhere. Between 25 to infinity can see somewhere. That is a near point of so here. So here you can see, here you can observe. So I hope it is clear now. Now it is clear? Yes or no? No, yes. The person can able to see infinity point, but he can't able to see near point. 25 centimeter he can't able to see. So for the correction, okay, so we are used, so between 25 to infinity, he can see somewhere. He can see somewhere. Between 25 to infinity, he can see somewhere. That point is called near point of hypermetropic eye, near point of hypermetropic eye. So now I will draw the diagram, just check once. So this is the near point of hypermetropic eye. Metropic eye. So this is the hypermetropic eye. Hypermetropic eye. So this is about correction of hypermetropic eye. Correction of hypermetropic eye. Correction of hypermetropic eye. Yes or no? Is it clear now? So now you can see, now you can observe, light rays are here. As I said, light rays are coming from N dash, that is the near point of hypermetropic eye. Light rays will meet at retina. Light rays will meet at retina. If the light rays are coming from, N, so those light rays will meet beyond the point. Beyond the point. Yes or no? So then we can able to see, can't able to see the near point. So near distance object. The person who has hypermetropia can't able to see. Yes or no? If you are taking here, so by using convex lens, dun, dun, dun. Convex lens. This is a convex lens. We are using convex lens to correct the defect of. We are using convex lens to correct the defect of. Hypermetropia. To correct the defect of hypermetropia, we are using convex lens. We are using convex lens to correct the defect of hypermetropia. To correct the defect of hypermetropia, we are using convex lens. Yes or no? Is it clear? So I hope it is very clear to you. So that is about hypermetropia. So you can observe here hypermetropia. Now, so from the near point, the light rays will meet at retina. If the light rays are coming from N, so 25 centimeter, we can't able to see because light rays will meet beyond retina. Okay, so here, if the light rays are coming from N, the light rays will meet at retina. So I am taking this is N. Is it clear? So this is about hypermetropia. Far distance we can see, near distance we can see. Far distance we can see, near distance we can see. Hypermetropia. For that correction, we are using convex lens. Hypermetropia. Convex lens. Yes, so this is about myopia and hypermetropia. Next one, presbyopia. Presbyopia is nothing but the person who has both near point, then nothing but myopia and hypermetropia. The person can't able to see near distance as well as far distance. The person can't able to see near distance as well as far distance. For the correction of presbyopia, we are using bifocal lens. We are using bifocal lens. Bifocal lens is nothing but upper portion is concave lens, lower portion is convex. Astigmatism. Astigmatism is nothing but a milky and cloudy will form on the eye lens. So by using laser surgery only we can remove the defect. By using laser surgery only we can remove that defect. Yes or no? So that is about cataract. Astigmatism. Astigmatism is nothing but the person can't able to see near distance as well as far, like horizontal lines as well as vertical lines. The person can't able to see horizontal lines as well as vertical lines. The person can't able to see. So the person can't able to see horizontal lines as well as vertical lines. So by using suitable cylindrical lens, 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 so we can correct the defect of astigmatism. We can correct the defect of astigmatism. Astigmatism. I hope it is very clear to you all. Yes, yes, yes. Now we are going to the one more. We are going to the one more. That is prism. 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 So rainbow formation by prism. So we'll discuss about it. Now, 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 light ray is passing through the prism, triangle prism. So you can see here. So if the light ray passing through the prism, it's split into 7 colors. If the light ray passing through the prism, it's split into 7 colors. So these 7 colors, when light ray passes through the prism, when light ray passes through the prism, light ray passes through the prism, violet, indigo, blue, green, yellow, orange, red. Vibgea. So violet, indigo, blue, green, yellow, orange, red with GR. Okay. So now you can see if the light ray passing through the prism, if the light ray passing through the prism, it's split into 7 colors. It's split into 7 colors when the white light passing through the prism. It's split into 7 colors. The splitting of white light into 7 colors is known as dispersion. The splitting of white light into 7 colors is known as dispersion. The band of colors will form on the screen, that is called spectrum. The band of colors will form on the screen, that is called spectrum. Splitting of white light into 7 colors is known as splitting of white light into 7 colors is known as dispersion. Those band of colors is known as spectrum, spectrum, spectrum. Yes, yes. Now, actually, Newton sent the white lights. Newton sent the white light through a prism. So those the light will split into 7 colors. Again, you want to split further. He placed a normal prism besides of the first prism. He didn't get anything. Then he placed the inverted prism. Inverted prism besides of that. Inverted prism besides of that. So he got white light as outcome as a white light. White come as a white light. Now we can see. So now, can we discuss recombination of spectrum of white light? So when white light passes through prism, split into 7 colors. When the light ray passes through the prism, split into 7 colors, those 7 colors will form on the second prism. So that is placed in inverted position. So those 7 colors again it will be combined and form as a white light. So this is about recombination of spectrum of white light. So this is the rainbow formation by prism. Rainbow formation by prism. This is about a recombination of spectrum of white light. Now we'll discuss about one more thing, that is so here if the light ray is passing through the water droplet, if the white light ray passes through the water droplet, it's split into 7 colors. It's split into 7 colors. Okay. So those 7 colors internally reflection takes place will come out as a white light. Will come out as a rainbow. Sorry, we come so that will come out as a rainbow. So now we'll see here. So here, if the light ray passing through the light ray passing through the prism, actually prism, each water droplet act as a prism. Each tiny water droplet act as a prism. Each tiny water droplet act as a prism. So when the light ray passing through the water droplet, when the white light ray passing through the water droplet, it's split into 7 colors. Those are rift. That is the phenomena involved in the formation of rainbow. The phenomena involved in the formation of rainbow. What are those? Refraction, dispersion, internal reflection. So what is the phenomena involved in the formation of rainbow? What is the phenomena involved in the formation of rainbow? Refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. So that is the phenomena involved in the formation of rainbow. 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 Yes or no? Yes or no? So this is about rainbow formation by water droplet. Rainbow formation by water droplet. And one more thing. So we can go to the scattering of light. Scattering of light is nothing but the re-emission of light in different directions with different intensity. The re-emission of light in different directions with different intensity is called scattering of light. The re-emission of light in different direction with different intensity is called scattering of light. Scattering of light is nothing but the re-emission of light in all directions. We can say all directions. The re-emission of light in all directions with different intensity is called scattering of light. Atmospheric refraction. Refraction takes place by the atmosphere. Refraction takes place by the atmosphere is called atmospheric refraction. Refraction takes place by the atmosphere is called atmospheric refraction. Atmospheric refraction. Atmospheric refraction. So, regarding the colors, sky appears blue color. Sky appears sometimes reddish in the morning and evening, and white color in the noon time. So these all colors regarding the due to the phenomena of scattering of light, and we can go through the Tyndall effect. The path of the light becomes visible. The path of the light becomes visible when it is passing through the colloidal solution. The path of the light becomes visible when it is passing through the colloidal solution. That is about Tyndall effect. So if you like this video, please do like, share, and subscribe to Student the Brand. So if you like this video, please do like, share, and subscribe to Student the Brand. So thank you so much for joining and attending the class. So if you like this content, if you like the channel, so you can subscribe my channel, and you can share to your friends, ask them to join to the class. Thank you so much. So this is Vaswasa from Student the Brand. Thank you.